Consider solving this quadratic equation for x by completing the square. Here we have the standard form of a quadratic equation where a, b, and c are any arbitrary coefficients. If we wanted to complete the square here, the first thing that we would need to do is to isolate the terms that have an x in them. So we'll subtract a c from both sides. Next, what we need to do is make sure that this leading coefficient is 1. For all the polynomials that we completed the square on, we had a leading coefficient of 1, so we'll need to ensure that. Let's divide by a to make sure that this leading coefficient is 1. That gives me an x squared plus b over ax equals negative c over a. Then I want to go ahead and complete the square. Remember that when we do this, we're taking half of that middle term, so half of b over a. When I do that, I get a b over 2a, and we need to square that. It gives me a b squared over 4a squared. Now we'll have to add a b squared over 4a squared to the other side as well to keep our equation balanced. Now I can go ahead and factor the left side. It gives me an x plus b over 2a quantity squared equals, and on the right side I need to go ahead and multiply this first fraction by 4a over 4a so that I can get a common denominator to add those fractions. So that gives me a negative 4ac over 4a squared plus a b squared over 4a squared. And then I can go ahead and add those numerators. So I have a b squared minus 4ac all over 4a squared. And of course the left side is still x plus b over 2a quantity squared. Then we'll want to take the square root of both sides now. Remember the plus minus when you do that. That gives me an x plus b over 2a on the left and a plus minus square root of b squared minus 4 times a times c all over a 2a. I can go ahead and take the square root of 4a squared. And let's go ahead and isolate x completely by subtracting b over 2a from both sides. When I do that, I see that I have a common denominator of 2a, so I can go ahead and put those two fractions together. This gives me x is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. This is what is known as the quadratic formula. More formally stated here, the quadratic formula, solutions to ax squared plus bx plus c equals 0 with a not equal to 0 are given by the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. For us to be able to use this formula, we have to have our equation in standard form where everything's on one side equal to 0. In descending order, identify the a, the b, the c. A is always the coefficient of x squared. B is always the coefficient of the plane x. And c is always our constant. Let's use the quadratic formula here to solve the equation. Then we'll support our results graphically. If there are no real solutions, say so. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Since our equation is already in standard form, I can just identify my a, b, and c. A is 2, b is 11, c is a negative 6. So putting that into the equation, I'll have x equals the opposite of 11 plus or minus the square root of 11 squared minus 4 times 2 times negative 6, so that'll be a negative 48 all over 2 times a, which is 4. So x is negative 11 plus or minus the square root of 121 plus 48, 169, all over 4. So x is a negative 11 plus or minus the square root of 169 is 13, all over 4. So x is a negative 11 plus 13 is 2, divided by 4 is 1/2, or negative 11 minus 13 is negative 24, divided by 4 is negative 6. Now we'll go ahead and confirm this graphically. Go ahead and turn on the calculator. We'll go to the y equals equation editor and put the left side of this equation in for y1. So 2x squared plus 11x minus 6, and go ahead and graph that. Get a nice graph of the equation, and what we'll want to do is find out where this graph equals 0, where the y value is 0, because we actually have a 0 instead of a y there. So second, calculate the 0, and we'll use our cursor buttons here to move our cursor to the left of the 0, hit enter, and then to the right of the 0 and hit enter, and then have it guess, and we get this 0 of a negative 6, and y is this very small number. Basically it's approximating 0 for us, and so that confirms the negative 6 as one of our solutions. And let's try finding the 0 here. So again, we'll go second, calculate is 0, and let's move our cursor so that we're a little closer to that 0 that's on the right, and hit enter. We'll go to the right of it and hit enter, and then we'll go ahead and hit enter in, again, to have the calculator guess, and it confirms that our other solution was a half. Let's solve by using the quadratic formula for the next couple of problems. If there are no real solutions, say so. We won't confirm these graphically, but you can go ahead and do that on your graphing calculator if you would like. So again, this is already in standard form for us. Let's go ahead and identify our a, b, and c values and state the quadratic formula. It's negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now let's substitute in the values that we have for this equation. Negative of b, so negative 2, plus or minus the square root of b squared, which is 4, minus 4 times a times c. So a times c is a positive 3, times 4 is 12, all over 2 times a, we get a negative 6. So this is x is negative 2 plus or minus the square root of negative 8 all over negative 6. Here we can see that we'll have no real solutions because we're being asked to find the square root of a negative. If we would like, we can go ahead and find the complex solutions and put them in a plus bi form. So if we did that, we'd have a negative 2 plus or minus 2i square roots of 2 all over negative 6. Now I see that every term is even. I can divide a 2 out of each of those. So I get a negative 1 plus or minus I square roots of 2 all over negative 3. Now when I put this in a plus bi form, I get a negative 1 over negative 3, which is 1/3, plus or minus the square root of 2 over 3i. Let's solve this one using the quadratic formula. We have a lot of work to do to even start the problem here because it's not in standard form. I have some multiplication that I need to do here. So let's start on that. X squared minus 1 plus 2 equals 4x. Now let's subtract 4x from both sides so that we can get it in one side equal to 0. So x squared minus 4x, and I know negative 1 plus 2 is a plus 1, equals 0. And state the quadratic formula along with your values of a, b, and c. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is negative of b, so negative of negative 4 is positive 4, plus or minus the square root of b squared is going to be a positive 16, minus 4 times 1 is just 4, all over 2 times a, so just a 2 there. That gives me 4 plus or minus the square root of 12 all over 2, and we want to simplify this radical. Remember that 12 is 4 times 3, so we get a 4 plus or minus 2 square roots of 3. The 4 comes out as a 2 all over 2, and x is dividing by 2, 2 plus or minus the square root of 3. So we have that nice solution. You notice it's not rational. We have a radical in it. So even if we had tried to solve this with factoring, there's no way we can. You can see there's no factors of 1 that add up to negative 4. So we can still get a solution whether it's rational or not. Whether this can be factored or not. So this can be used for those polynomials, the quadratic equations that are not factorable. The discriminant in quadratic equations. To determine the number of solutions to the quadratic equation ax squared plus bx plus c equals 0, evaluate the discriminant b squared minus 4ac. Now if you state the quadratic formula, you'll notice that the b squared minus 4ac is the radicand of the radical. So depending on what kind of number that is determines how many solutions we'll have to our equation. If we're looking at that number being positive, then there will be 2 real solutions. So if this is positive, we'll have a negative b plus that number and a negative b minus that number all over 2a. So 2 real solutions. If it equals 0, on the other hand, then the plus minus part goes away. If this has a value of 0, the square root of 0 is 0, and we don't need to be adding 0 to negative b in order to get our solutions. So we'll just have 1. If that number is negative, then we will have no real solutions, but we will have 2 complex solutions to the equation. A graph of y equals ax squared plus bx plus c is shown. First we're going to state whether a is positive or negative. We'll solve ax squared plus bx plus c equals 0 if possible. and then we'll state whether the discriminant is positive, negative, or 0. So first of all, let's state whether a is positive or negative. Here I have a parabola that's opening down, so that means that the a must be a negative number. If I wanted to solve this equation equaling 0, and I have the graph of that equals y, then I just need to find on the graph where y is 0. That would be here and here. So x equals -3 or -1 are my two solutions. Now since I have two real solutions, that must mean that my discriminant was a positive number. Here I have a parabola that's opening up, so a must be positive. If I try to solve this, there are no places on the graph where y is 0 because the graph doesn't dip down low enough in order to cross that x-axis. So there are no real solutions here. That must mean that my discriminant was a negative number because I have no real solutions, only two imaginary solutions. Here again I have the parabola opening up, so a is positive. If I wanted to find the solution, it's sitting right there. The vertex is right on the x-axis, so I have just that one solution of x equals +5. For the discriminant, that must mean that my discriminant was 0 because I have just one solution, which eliminates the plus or minus part of the quadratic formula. Let's use the quadratic formula to find any x-intercepts on the graph of this equation. Now we're not even going to graph this equation, we'll just find algebraically those x-intercepts. Think of what it means to find an x-intercept in the first place. It means that the y is 0. So if I make my y 0, I can try and find the x-intercepts. Now I cannot factor this, so I definitely will need to use some other method. So we'll use the quadratic formula to find it. So my quadratic formula again is x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is the opposite of -2, so +2, plus or minus the square root of b squared, which is 4, minus 4 times 1 times -1, so that makes it a -4, all over 2 times a, which is 2. So x is 2 plus or minus the square root of 4 plus 4 is 8 all over 2. So continue this over here. I have an x is 2 plus or minus 2 square roots of 2 all over 2, which we can simplify as 1 plus the square root of 2. That's being divided by 2, and this is being divided by 2. So I found a solution for that equation equaling 0, so my x-intercepts would be 1 plus the square root of 2 comma 0 and 1 minus the square root of 2 comma 0. Let's find the x-intercepts of this graph. So again, I start out with making y equals 0, and I'm going to use my quadratic formula. So x is negative of b plus or minus the square root of b squared minus 4 times -2 is a -8 times 3 is a -24, so it makes it a plus 24 all over 2 times a. So that's a -4. That gives me 1 plus or minus the square root of 25 all over negative 4. So x is 1 plus or minus 5 all over negative 4. And that gives me a nice clean solution of 1 plus 5 is 6 over negative 4, a negative 3 halves. Or 1 minus 5 is negative 4, divided by negative 4 is positive 1. If I wanted to state my x-intercepts, they would be negative 3 halves, comma 0, and 1, comma 0. Solve the equation, write complex solutions in standard form. Here we could use just the square root property in order to solve, but let's practice using the quadratic formula. So on this one we have an a value of 1, a b value of 0 because we have no plain x term, and a c value of 80. So we have x is negative b plus or minus the square root of b squared minus 4 times a times c. So 4 times 80, we have a negative 320 there, all over 2 times a. So x is 0 plus or minus the square root of negative 320 all over 2. Let's go to the side here so that we can simplify the square root of negative 320. I do know it's 2 times 160. That's 2 times 80. That's 2 times 40. That's 2 times 20. 2 times 10. 2 times 5. So I have a 1, 2, 3, 4, 5, 6, 6 2's under there. When I take the square root, it'll be 2 to the third with a square root of 5 underneath. And of course I know I'm taking the square root of a negative, so I'm going to have an I all over 2. So that's a plus or minus 8 divided by 2 is 4i square roots of 5 plus or minus. So those are my complex solutions in standard form. Let's solve this using quadratic formula. So x is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is 1 plus or minus the square root of negative 7 all over 2. And in complex form, it'd be 1/2 plus or minus the square root of 7 over 2i. Modeling stopping distance. Use d equals 1/9 x squared plus 11/3 x to find a safe speed x for the following stopping distance d. So they've given us a d value. That means we'll just put that in for d in the equation. So 42 is 1/9 x squared plus 11/3 x. And we want to try and solve this. It's quadratic, so we can use the quadratic formula if you like. One thing that you'll need to do is get it in standard form, where everything's on one side equal to 0. Another thing you might want to do is multiply both the sides of the equation by 9 in order to get rid of those fractions so that we don't have fractions within fractions. So that would give me a 0 equals x squared plus a 9 times 11/3, 3 would go into 9 3 times, so we get a 33x minus 42 times 9. Get a 42 times 9, 378. Now I want to put this into the quadratic formula. So x is negative b plus or minus the square root of b squared. So 33 squared is 1089 minus 4 times 1 times negative 378. So 4 times 378. I get 1512, and that was a negative 1512, so it's going to be a plus 1512 all over 2 times a, so just a 2 there. It gives me x is negative 33 plus or minus the square root of 1089 plus 1512, and we get 2601, 2601 all over 2. So x, the square root of 2601 is 51. Now if I take negative 33 and I subtract, use the minus, subtract 51, I'm going to get a negative number divided by 2. That wouldn't be a viable speed to be going a negative miles per hour. So we're only going to be using the negative 33 plus 51, and then we'll divide that by 2. So we get a 9 anyway, and that's actually an exact answer. So x is 9, and so the 9 would be 9 miles per hour. And that covers this section. Go ahead and try your homework. Be sure to let me know if you have questions.